math enthusiasts. Welcome to the section 7 of integrals. In this section, we're gonna to speak about trigonometric substitution. But before that, I'm gonna to clarify something is so important. You know, guys, integration is a little tricky because, for example, if you're gonna to calculate derivative, it's not so hard, and every function, every formula, if I tell you yes, immediately you can calculate it. Integration procedure is not like this. For example, if I tell you this integration has a one method for solving, and by little change, just by x, the procedure is totally different. And if I put by x power 2, the procedure are also totally with before. Okay? But in the past, we speak about these two one, and if you can't solve this form of integration, I tell you, please come back and start from section 1. In this journey, we're gonna to calculate and learn together integration from 0 to hero. And also, I must tell you, if you are a new member, please subscribe and ring the bell. But today, I'm gonna to discuss about how we can get rid of the radical. 90%, if you can get rid radical, your solution can solve the better. Therefore, if we're gonna to delete the radical, it depends on the circumstances. If your radical is in this form, a power 2 minus x2, you must use this substitution. X equal a sine theta. Also, must theta be between minus pi over 2 and pi over. Why? Because we're gonna to use by inverse function, and you know the sign must in this domain is inversible. Or another one, if you're gonna to delete this form of radical a power 2 x squared, you must use this substitution, a tangent theta. And if you're gonna to delete this radical, x power 2 minus a squared is your substitution, 1 over cosine theta. Also in here, exactly the same, but about the cosine, we just take the first quadrant or second quadrant, because in this quadrant, cosine is positive and our inverse also is positive. Although that is not so important, and you must know this trick. It can help you to calculate the question. For example, but can you tell me what is the difference between this factor? Yes, in this factor, the constant is in the first minus with x squared. But in this one, x squared is in the first and our constant is second stage. And if we're gonna get rid of this radical, we must use this substitution, and after that we change the splitting of integrals and we can calculate so better. As an example, you consider we have integration x power 2 9 minus x power 2 dx. Therefore, if I substitute x as a 3 sine theta, because in here our a power 2 is 9 and a is 3, it's so simple. But if we're gonna to calculate differentiate of x is exactly 3 cosine theta. But about this, how we can get rid of this integration? 9 minus 3 sine theta power 2 is exactly 9. I take a factorate, 1 minus sine theta power in radical. Am I right? By trigonometry identity, 1 minus sine power 2 is exactly cosine theta power 2. If we're gonna to take root square, is absolute value of 3 cosine theta. But as I mentioned earlier, in here theta is between minus pi 2 and pi 2. Yes, in this part we know cosine x positive. If you don't know, please come back to our trigonometry course. I tell everything with detail, and therefore that is in the first and fourth quadrant is positive, and answer is 3 cosine theta. Right now, let's let's come back to our substitution. Integration of 9 sine theta power 2 divided to 3 cosine theta times our dx is exactly 3 cosine theta d theta. Yes, because in here we take the derivative with respect to theta. Immediately they can cancel each other. Our answer is 9 integration of sine theta power 2 d theta. If you follow our previous session, you know if we're gonna to calculate sine theta with power 2, reduction power rule, and it is exactly 1 minus cosine 2 theta divided 2. I proved that in the previous session. Okay, I can substitute in here is 1 minus cotangent 2 theta. I put this factor in the out is 9 over 2 d theta. Therefore, if we're gonna to calculate this integration is 9 over 2 theta. If we're gonna to calculate minus cosine, we know that is cosine, sine, minus cosine, and minus sine. Yes, if we're gonna to calculate this integration, we must go counterclockwise. Therefore, answer is minus sine 2 theta, but divided to with respect to previous session plus c. But we know from trigonometric ratios sine 2 theta exactly is 2 sine theta times cosine theta. Am I right? I put in here is theta 2 and 2, they can cancel each other, minus sine theta times cosine theta plus by c. Yes, but in here if I gonna to calculate sine and cosine exactly, I suppose x equal to 3 sine theta. Yes, therefore sine theta x over 3. Yeah, okay, if I take the inverse from both sides, theta equal to sine minus x over 3, and if you consider this right angle as a theta with respect to sine, this opposite is x and our hypotenuse is 3. This part is 9 minus x power 2. Yeah, with respect this right triangle, cosine theta is exactly implies that 9 minus x power 2 divided 3. Therefore our total answer is theta is sine inverse of x over 3 minus x over 3, cosine is that, and cosine I calculated radical 9 minus x power 2 divided 3 plus by c. Okay, let's go to another question. Integration e 1 over x power 2 radical x power 2 plus 4 dx. If we're gonna to get rid of this form of radical a power 2 plus x power 2, we must substitute x by, tell me, yes, tangent theta multiplied by, yes, a. Thank you for your guidance. But right now if I gonna to calculate is x to tangent theta, and if I gonna to calculate differentiate of x is 2 1 plus tangent square d theta, and if I gonna to calculate this is radical 4 tangent square plus 4, and if I factorate 4 is 1 plus tangent of course theta over 2, and we know by trigonometry, if you don't know it's not my fault, you can follow it in the playlist, but is 1 over cosine theta over 2. If I take the root square, answer is 2 over absolute value of cosine theta, and because we are in the tangent, we are in this section, cosine also is positive, and our answer is 2 over cosine. Okay guys, let's substitute this new variable for initial formula. Therefore this integration dx is exactly this one is 2 1 plus tangent square theta d theta. Yes, but about x power 2 is 4 tangent square theta, but about this factor here we calculate in here, but we cancel this is 2 over cosine theta. But we know 1 plus tangent power 2 is cosine theta squared. Yes, but this and this can cancel. If I gonna to this one and this one is cancel, but at the last is integration of 1 over 4 integration 1 over cosine theta divided to sine theta squared cosine theta squared. Yes, how we can calculate this? Yes, this part in the top and this one in the bottom. For is 1 over 4 integration cosine power 2 theta divided to sine power 2 theta times cosine. Yes, this part in the denominator d theta, but also this one and this one can cancel each other. Okay, total integration is 1 over 4 integration cosine theta d theta divided to sine theta power 2. Yes, but how we can calculate this? Right now by substitution, if we suppose sine theta is exactly u, cosine theta d theta is exactly du. Yes, I substitute in here and answer is integration of course 1 over 4 du u power 2. It's simple because it's u minus 2. This integration du is u minus 1 divided minus 1 with 1 over 4 plus c. But if I gonna to substitute by sine is 1 over 4 minus sine, it goes to the numerator is 1 sine theta by minus plus. But our answer is finished? No, not at all, because we achieved to the something with respect to theta. We gonna to calculate and we obtain to x. Yes, but right now we must use triangle. In the triangle we suppose x equal 3 tangent theta. Yes, so x over 3 is tangent theta is exactly, if suppose that is theta, tangent meaning is opposite to adjacent, and this part is 9 plus x squared. What we must gonna to calculate? Sine theta. Okay, the sine theta is x over radical 9 plus x2. Am I right? But at the last I substitute in here. This question is existence is hard. Yeah, okay, thank you for watching this video, because I know you must be crazy about the mathematics you stay in this journey, because some of the people I know, they passionate about learning and they gonna to understand these complex questions. Okay, but the last one, x equal to secant theta or 1 over cosine theta. Let's produce an integration for this substitution. You consider, for example, if we're gonna to calculate integration dx, I don't know, root square of x power 2 minus 1. Okay, if I suppose x equal to 1 over cosine theta, you know our dx is exactly, if we're gonna to calculate derivative is cosine theta power 2, and this factor derivative is 0, but this is minus sign. Yes, but because I don't gonna to say, but sometimes I prefer, because I know some of the people are so weak. If you're gonna to calculate derivative is v power 2 u prime times v minus v prime times u. Yes, this one is 0, but the cosine is minus sign times 1 minus 1, but with the minus is exactly sine. Yes, okay, but get rid of this nasty radical. It causes a problem for us. The radical 1 over cosine theta power 2 minus 1 is exactly cosine theta power 2 1 minus cosine power 2 in root square. We know by identity of trigonometry that is sine theta power 2, and our answer is absolute value of sine theta divided to cosine, and we limited our domain and that is positive. For answer is sine theta divided to cosine. Okay, let's go to the substitute. Integration integration of dx exactly is this. I put in here sine theta over cosine theta by power 2d theta, because this integration, of course, the derivation is with respect to theta, and divided to this radical answer is this, is sine theta divided to cosine. At the here, if I multiply this in the numerator, is sine theta cosine theta divided to sine theta times cosine to integration. Immediately they cancel this one by this one, and our total integral is 1 over cosine theta d theta. And exactly I calculated in the previous session, and if you're gonna to understand how we must calculate this, please start by 0. Thank you for watching and give your valuable time for me. Please like and take a comment for me, because I told you it's take me energy. I see you in the next video. Take care. Bye bye.